Good morning, everyone. This is Payavala Bhavgna from Institute of Aeronautical Engineering, IARE. I am from the branch Computer Science and Engineering, Section A. My roll number is 24951A0559, and I am here to explain a topic called non-homogeneous equation in education from the subject differential equations in vector calculus. Now let us quickly dive into the introduction. Now, introduction to non-homogeneous equations. Non-homogeneous equations are differential equations with a non-zero term on the right-hand side. That means there is an equation on the right-hand side instead of a zero, there is a non-zero term. If there is a zero, that is considered as a homogeneous equation. They play a significant role in various fields, including physics and engineering. Understanding these equations is essential for students in advanced mathematics and applied sciences. Now let us know about this non-homogeneous equation in detail. A non-homogeneous is a differential equation that includes a non-zero forcing function or non-homogeneous term. It takes the general form L of y equal to f of x. When L of y is a linear differential operator acting on y and f of x is a given function that is not identically zero, the presence of f of x makes the equation a non-homogeneous, distinguishing it from homogeneous equations where f of x equal to 0. Non-homogeneous linear ODE is y double dash plus 3y dash minus 4y equal to e power x, which means the right hand side the term is a non-zero term, meaning it is a non-homogeneous equation. The general solution of a non-homogeneous equation consists of complementary solution to the associated homogeneous equation, and a particular solution, specific solution satisfying the non-homogeneous equation. Now let us see some examples of non-homogeneous equation. An example of non-homogeneous linear equation is y double dash plus 3y dash plus 2y is equal to e to the power t. The right hand element is not 0 as we know. Another example is y dash minus 4y equal to sine t, meaning again the right hand element is a non-homogeneous because it is a non-zero element. These examples illustrate how the non-homogeneous part influences the solution. Here we also have another example for non-homogeneous equation. It is a third degree differential equation y triple dash minus 3y dash plus 3y dash minus y equal to x minus 4e per x. Now let us know about the importance of non-homogeneous equation in education. Non-homogeneous equations are essential in teaching differential equations in higher education. They help students understand real-world applications such as physics and engineering. Mastering these concepts builds a strong foundation for advanced problem-solving skills. Non-homogeneous equations are crucial in education as they help model real-world problems in physics, engineering, and economics. They enhance problem-solving skills, critical thinking, and understanding of external influences in dynamic systems. Their study bridges theoretical math with practical application, preparing students for careers in STEM and computation fields. Non-homogeneous equations are crucial in education as they help model real-world problems in physics, engineering, and economics. They enhance problem-solving skills, critical thinking, and understanding in external influences in dynamic systems. Their study bridges theoretical math with practical application, preparing students for careers in STEM and computation fields. Applications in real life. Non-homogeneous equations model various phenomena, including forced vibrations in mechanical systems. They are used in electrical engineering to analyze circuits and external forces. Understanding these applications enhances students' engagement with mathematics. Now let's know about the methods of solving non-homogeneous equation. Common methods include the method of undetermined coefficients and variation of parameters. Each method has specific criteria for applicability based on the form of the non-homogeneous term. Familiarity with these methods is crucial for students to tackle complex problems. The method of undetermined coefficients. This method involves guessing a particular solution based on the form of non-homogeneous term. Students learn to derive coefficients by substituting back into the original equation. It is particularly for polynomial exponents and trigonometric functions. Variation of parameters. Variation of parameters provides a systematic approach to finding particular solutions. It involves using known solutions of the corresponding homogeneous equation. This method is more versatile and can be applied to a broader range of non-homogeneous terms. Now here we have some variation of parameters, which are y double dash minus y 5y dash plus 4y equal to e to the power 3t. Homogeneous equation is this one, um, which which has the right hand term as 0, and characteristic equation is r square minus 5r plus 4 equal to 0. Now here r1 equals to 4, r2 equals to 1. Same goes with this one. U1 is minus integration of y2 gt by w y dash y2 dt equals to minus 1 by 3 e to the power minus t plus c. Same with u2, and you'll get this yh, and yh is nothing but c1 y1 plus c2 y2. And once you substitute the whole thing here, you get w y dash y2 g y1 y2. Yeah. Challenges in learning non-homogeneous equation. Students often struggle with the transition from homogeneous to non-homogeneous equation. The complexity of methods can overwhelm learners without a solid foundation. Addressing these challenges requires tailored teaching strategies and practice. Now we all know homogeneous equations are nothing but when the right side term is 0, a zero term, and non-homogeneous is simply when the right side term is a non-zero term. For example, 3x square minus 2x plus 3 equals to 0 is a homogeneous equation, and 3x square minus 4xy plus 2 equals to e to the power x is a non-homogeneous equation. Since the right side part is a non-zero term, it is known as non-homogeneous equation. Pedagogical strategies. Incorporating technology such as graphing calculators can aid in visualizing solutions. We all have this scientific calculator which we use in our daily life, and while we calculate something. Collaborative problem solving activities encourage peer learning and engagement. Real life applications can make the subject matter more relatable and interesting. Role of technology in education. Software tools like MATLAB and Mathematica can simplify solving non-homogeneous equations. Online platforms provide interactive tutorials and resources for self-paced learning. Technology enhances students' understanding and retention of complex concepts. By using a scientific calculator, we can easily find its roots uh, from an homogeneous equation. All we need to do is simply give the a, b, c values in there, and the which type of degree uh, equation is that. If it is a polynomial, it is a 3 degree. If it is a quadratic equation, it is a 4 degree, etc. Assessment techniques. Formative assessment can gauge students' understanding of non-homogeneous equation. Incorporating project-based assessments allows students to apply concepts creatively. Regular quizzes and problem sets can reinforce learning and identify areas for improvement. Integrating non-homogeneous equation in curriculum. Non-homogeneous equation should be introduced early in differential equation courses. Curriculum integration helps students see connections across various mathematical concepts. Aligning content with real world applications increases relevance and student interest. Case studies in education. Research shows that students who engage with applied problems perform better in assessment. Case studies can demonstrate the effectiveness of different teaching methodologies. Analyzing students' feedback helps refine industrial approaches for non homogeneous equations. Now, let's see about the future directions in teaching this non homogeneous equations. There is a growing need for innovative teaching methods in mathematical education. We all know that there is a growing need for people always look forward to a different style of teaching to understand better and to grasp things better. So we all know that there is a growing need for innovative teaching methods in mathematics, especially in mathematics education. Blended learning approaches combined traditional and online industry instructions for flexibility. Ongoing professional development for educators ensures they remain effective in teaching complex topics. Now there is an article on this because of the need and the demand that this problem has, teaching mathematics with innovative methods. Collaborative learning environment. Group work fosters collaboration and enhances problem solving skills among students. Group work is always a better option to understand better, to learn better, to engage better, to anything. Peer teaching allows students to articulate their understanding and clarify concepts. Creating a supportive classroom atmosphere encourages risk taking and exploration of ideas. Now, importance of conceptual understanding. Fostering a deep understanding of non-homogeneous equations is crucial for students' success. Conceptual knowledge enables the students to apply techniques effectively in various contexts. Emphasizing connections between theory and application enhances the learning experience. Now, let us know about the resources for educators who teach this. Numerous textbooks and online resources are available to assist in teaching non homogeneous equations. Professional organizations often provide workshops and conferences focusing on the mathematics education. Utilizing these resources can enhance instructional quality and student engagement. Now let's get to the final thoughts on non-homogeneous equation. Mastery of non-homogeneous equations is vital for students pursuing STEM careers. Educators play a crucial role in demystifying these concepts and fostering interests. Continuous improvement in teaching practices will lead to better educational outcomes.